To simplify these trigonometry terms, we can use double angle formula of the sin 2 theta. We know sin 2 theta equal to 2 sin theta into cos theta. So in here, sin 2x value we can write as 2 sin x cos x. Similarly, sin 30x we can write as 2 sin 15x into cos 15x. Sin 6x value we can write as 2 sin 3x into cos 3x, and sin 10x value we can write as 2 sin 5x into cos 5x. Then we can cancel out all the term of the sine in the numerator and denominator. After that, we can get cos x into cos 15x over cos 3x into cos 5x perfect square. To simplify this trigonometry expression, we can use triple angle formula of the cos 3 theta. We know cos 3 theta equal to 4 cos cube theta minus 3 cos theta. So in here, cos 15x value we can write as 4 cos cube 5x minus 3 cos 5x, and denominator cos 3x value we can write as 4 cos cube x minus 3 cos x. Now we can get cos 5x as a common factor in the numerator. Similarly, we can get cos x as a common factor in the denominator. After that, we can cancel out numerator cos x value and denominator cos x value. Similarly, we can cancel out numerator cos 5x and denominator cos 5x value. Then we can get the result 4 cos squared 5x minus 3 over 4 cos squared x minus 3 perfect squared. We know cos squared theta value equal to 1 plus cos 2 theta over 2. In here, cos squared 5x value we can write as 1 plus cos 10x over 2, and denominator cos squared x value we can write as 1 plus cos 2x over 2 using this formula. Then we can cancel out numerator value 4 and denominator value 2. After that, we can get 2 times 1 plus cos 10x minus 3 over 2 times 1 plus cos 2x minus 3. We can remove the bracket and simplify the function and get the result 2 times cos 10x minus 1 over 2 times cos 2x minus 1 perfect square. Okay, this is the place where most people get stuck. There is no simple trigonometry formula to convert this function to a simple form. So we can think a little bit differently. To simplify this function further, we can use Euler's formula. Using Euler's formula, we can express cos theta or sin theta term using complex numbers. So in here, we can write e to the power of I theta equal to cos theta plus I sin theta. Similarly, we can write e to the power of minus I theta as cos theta minus I sin theta. We can add both these equations and we can get the result e to the power of I theta plus e to the power of minus I theta as 2 cos theta. So we can write 2 cos theta as e to the power of I theta plus e to the power of minus I theta. In this question, we need 2 cos 10x and 2 cos 2x trigonometry terms. 2 cos 10x value we can write as e to the power of I 10x plus e to the power of minus I 10x. Similarly, 2 cos 2x value we can write as e to the power of I 2x plus e to the power of minus I 2x. Using this simple e term and imaginary unit term I, simplification process is very complex. So we need to convert these trigonometry terms to simple form. Let's consider e to the power of ix as t. Then we can express 2 cos 10x value as t to the power of 10 plus t to the power of minus 10. Similarly, 2 cos 2x value we can express as t squared plus t to the power of minus 2. So now 2 cos 10x minus 1 over 2 cos 2x minus 1 value we can write as t to the power of 10 plus t to the power of minus 10 minus 1 over t squared plus t to the power of minus 2 minus 1. T to the power of minus 10 value we can write as 1 over t to the power of 10. T to the power of minus 2 value we can write as 1 over t squared. Now we can get common denominator in the numerator. Common denominator of the numerator is t to the power of 10. Then we can write t to the power of 20 plus 1 minus t to the power of 10 over t to the power of 10. Similarly, we can get common denominator in the denominator. Common denominator of the denominator is t squared. Then we can write t to the power of 4 plus 1 minus t squared over t squared. Then we need to simplify this function. Denominator value of the denominator we can write as numerator. So we can get the result t squared over t to the power of 10 into t to the power of 20 minus t to the power of 10 plus 1 over t to the power of 4 minus t squared plus 1. After that we can simplify t squared over t to the power of 10 as 1 over t to the power of 8. Now we need to simplify t to the power of 20 minus t to the power of 10 plus 1 over t to the power of 4 minus t squared plus 1 value. To simplify this one, we need to express numerator value from denominator value. Then we can cancel out numerator value and denominator value. To express numerator value from denominator value, we can use long division. Using long division, instead of t to the power of 20 minus t to the power of 10 plus 1 value, we can write t to the power of 4 minus t squared plus 1 into t to the power of 16 plus t to the power of 14 minus t to the power of 10 minus t to the power of 8 minus t to the power of 6 plus t squared plus 1. Now we can cancel out numerator value t to the power of 4 minus t squared plus 1 value for denominator value t to the power of 4 minus t squared plus 1. After that, we can divide all the terms of the numerator from denominator value t to the power of 8. Then we can get the result t to the power of 8 plus t to the power of 6 minus t squared minus 1 minus t to the power of minus 2 plus t to the power of minus 6 plus t to the power of minus 8. Then we can write t to the power of 8 plus t to the power of minus 8 terms together, t to the power of 6 plus t to the power of minus 6 term together, and t squared plus t to the power of minus 2 terms together. T to the power of 8 plus t to the power of minus 8 value we can get as 2 times cos 8x. Similarly, t to the power of 6 plus t to the power of minus 6 value we can consider as 2 cos 6x, and t squared plus t to the power of minus 2 value we can get as 2 cos 2x. Let's move to integration part. Instead of 2 cos 10x minus 1 over 2 cos 2x minus 1 value, we can write 2 cos 8x plus 2 cos 6x minus 2 cos 2x minus 1. Let's consider 2 cos 8x as simple A, 2 cos 6x as simple B, 2 cos 2x as simple C, and 1 as simple D. Then we need to find the integral of A plus B minus C minus D perfect squared. a plus b minus c minus d perfect squared value we can write as a squared plus b squared plus c squared plus d squared plus 2ab minus 2ac minus 2ad minus 2bc minus 2bd plus 2cd. Now we need to find the integral value of each term. However, this process is complex and time consuming. The most suitable approach is to find the integral value for the general term and then substitute this value for the terms in the expression. A squared equal to 4 cos squared 8x, b squared equal to 4 cos squared 6x, c squared equal to 4 cos squared 2x. So, if we can find the value of 0 to pi 4 cos squared kx, then we can find the value of a squared, b squared and c squared. In this integral, k is an integer. 4 is a constant, so we can bring 4 outside of the integral. Cos squared theta value equal to 1 plus cos 2 theta over 2. So instead of cos squared kx value, we can write 1 plus cos 2 kx over 2. Denominator value 2 is a constant, so we can bring denominator value 2 outside of the integral. After that, we can consider integral sign separately. Integral 1 equal to x and integral cos 2kx equal to sin 2kx over 2k. Then we can substitute upper limit and lower limit for these answers and we can get the result 2 pi. D squared equal to 1. So we need to find integral 1. Integral 1 equal to x. Then we can substitute upper limit and lower limit and get the result pi. To find 2ab, 2ac and 2bc value, we can consider integral 0 to pi 8 cos mx into cos nx value. Value of 8 we can write as 4 times 2. Then we can bring 4 outside of the integral. We know 2 cos a into cos b value is equal to cos a plus b plus cos a minus b. So in here 2 cos mx into cos nx value we can write as cos mx plus nx plus cos mx minus nx. After that we can consider integral sign separately. Integral cos m plus n into x value we can consider as sin m plus n into x over m plus n. Similarly, cos m minus n into x integral value we can consider as sin m minus n into x over m minus n. Here m and n are integers. So when we substitute upper limit and lower limit, we can consider sin m plus n into pi value as 0 and sin m minus n into phi value as 0. Obviously sin 0 is 0. Then we can consider final answer as 0. So 2ab, 2ac and 2bc integral value also equal to 0. To find integral 2ad, integral 2bd and integral 2cd value, we can consider 0 to pi 2 cos nx value. Here n is an integer. 2 is a constant, so we can bring 2 outside of the integral. Integral cos nx value equal to sin nx over n. After that we can substitute upper limit and lower limit. Sin n pi equal to 0 because n is an integer. Sin n times 0 means sin 0. Sin 0 value equal to 0. Then we can get the final answer as 0. So integral 2AD, 2BD and 2CD values also 0. So we can write final answer as 7 pi.